Guys, and a very warm welcome. In this video we'll be learning a bit about how can we read files, and not just a single file but multiple files that are sitting across different nodes in our cluster in different racks using the read operation in Spark. So we have a brief idea about the basic architecture of Hadoop distributed file system and this parallel computing framework, that our data is not just sitting on a single CPU, but it's rather sitting on multiple CPUs in different partitions within them. Like here, in case of data node, within the data node there are multiple racks, we can say, where data is stored in different parts. One part could be sitting on rack 1 while the other part of the data could be sitting on rack 2. So data is distributed across clusters, and this is how Facebook and Google store their data. So all of the data is not just sitting on one cluster, but rather it's distributed across different partitions, and each of that partition are located on different data nodes in racks, in their allocated racks, which are then taken into account by the name node. So name node only knows where each part of the data is sitting inside these data nodes in different racks. But then the question comes, how can you read this kind of data? It will be very difficult for any banking system to know that one day of transactions is sitting on, say, CPU 1, while the other day of transaction is sitting on CPU 5 or CPU 10, or there could be hundreds of CPUs for a banking cluster, and it can be really difficult for them to be able to locate this data if they are not using this kind of parallel computing and distributed architecture. So Spark takes care of all of this hectic work. But then the question comes that how can you read this kind of data in Spark? So let's learn how to do that. So I've opened my Databricks platform, and as we might be already having this basic idea that Spark Databricks is created by the Spark community by UC Berkeley. And so I have some files that are distributed across different partitions. Let me try to locate where are those files in that partition. So in Databricks, how we locate that is by doing fs ls. This is how we run Hadoop commands. So fs means file system, ls means list me the files inside this file system, and then I will locate that file. I will say dbfs, say my file store. So let me see where is my file inside my file store. So I'm accessing my file system right now. Is taking a bit of time. Yeah, it's here. So I have to go file sitting inside tables. So I will say tables here, and within that table there's a folder named output. Yeah, so let's load that output words, and then go type in words sentiment. Say you are looking to do some analysis, you're planning to do some analysis on Twitter, and you want to find out the kind of reviews or feedback people are writing upon the internet for your kind of products. Like, let's see this from a big data problem kind of view. So we'll go into the word sentiment here, here it says there is some problem in locating that. Yeah, that's word sentiments. I'll just type backwards, copy and paste this here. So like here there are two partitions sitting on my cluster, and these two partitions could be sitting on different racks, like we just discussed, that these two partitions, but one partition could be sitting on rack 1 while the other partition could be sitting on rack 2. But for our analysis, like if you're part of Twitter, if you're working for Twitter and some company says, okay, please give us a sentiment for this kind of products, or say you are some open source big tech giant and you took some Twitter APIs and said, okay, we'll do some analysis on Twitter and we'll let you know how is the feedback for your latest Samsung device, maybe for Samsung, maybe for Apple, what people are saying about the latest iPhone, maybe to do some better improvements here. So data could be in several different partitions. These are terabytes and exabytes of data, and now it's your job to sort out this data and get your relevant keywords, and then which of your tweets have iPhone keyword within them, or which of your tweets have this hashtag 10 years challenge or something like that, which you want to analyze for your project. So these 10 terabytes of file or 100 terabytes of file or 1 exabyte of file cannot fit in one part. These could be in different partitions like we are trying to load. So let's say we are doing this kind of analysis, and we have located the file that it's over here, and let's say now we want to load this file. How would we do that? So first of all, let's import our Spark configurations. These are some of the basic configurations which we have to import every time from these packages that are provided to us by the Spark community to help us with different functionality. So say from PySpark, I will first of all import my Spark configurations, and then I will import my Spark context. Once I import all of this configurations and my Spark context, I will denote my configurations. I will say my Spark configurations, and I will include the Spark context over here, and let's give this a name before coming to the Spark context, the Spark output for us. So we'll just say set my app name, and we'll just set this as reading, let's say multiple partitions. So this will help us when we are seeing our Spark configuration. This will help us understand in our cluster end that okay, we executed this job in the cluster on this day at this time. So it's a good practice to denote these kind of app names that help you understand. So we have denoted our Spark configurations, and let's import our Spark context now. This is our Spark context here. Let's say SC, which is Spark context. We can just assign it any name. I will just put Spark SC for better understanding and readability, and I will say Spark context, and there are different commands which we can use. So there is get configurations, and there is get or create. So what get or create does is it gets that configuration, or in case it's not there, we'll just create that. So we have a variable over here by the name configurations. We'll just do that, and then we'll import these 5 partitions. So let's do a small thing for better understanding. Let's say my RDD is equal to my SC, which is my Spark context dot text file, and I will just copy and paste this path from there to help me avoid any kind of errors here. And let's try to import just one part of the file, so we have better understanding of how data is being read. And we'll say, so for seeing the output, we say rdd.collect. Okay, let's try to run this, and there's some syntax error here. This has to be capital, and there is nothing here. So let's try the first path of that file, and there we have some part of the file. And now, so we see that data is coming in parts. Now let's say we want to import all of these parts that are sitting across different parts of our cluster, different nodes of our cluster in different racks. Like we just discussed, that data is sitting on different racks when the size goes beyond 100 terabytes. It could be a lot of work to store 100 terabytes of data on one CPU, and what will happen if in case that CPU fails or bursts into sheer piece of metal. You have to keep in account all of these things, as we are dealing with commodity hardware, and these are not supercomputers. This is just normal commodity hardware. And we can have a look now that we imported all of these partitions of files. So this was a brief demonstration of how we can import multiple partitions of files that are sitting across different racks and different nodes in our cluster with a simple command. We'll just specify the folder here, and in case it's sitting on different folders, we can move our file, we can copy the file, and we can do all of these operations on this. So, and yeah, we'll be doing more of these operations in our other lectures too. So do stay tuned, guys, and happy learning. We'll see you in the next one.